This is going to be the first video of several on solving rational equations. A rational equation is just an equation that contains one or more rational expressions, basically fractions. Now, this is a special type of rational equation. It is fraction equal to fraction, and because it is fraction equal to fraction, you can just cross multiply to solve. So do the top of this times this bottom, do the top of this times the other bottom, and you will have that equation. Now be sure you realize when you do this times this binomial, it's distributive property. Also, a big deal is this. When you cross multiply to solve, the equal sign comes down. When you cross multiply, you don't create another fraction, you are creating an equation. But this equation you have created does not have any more fractions, which is why cross multiplying is a good idea. But you can only use cross multiplying if it is one fraction equal to one fraction. So now we don't have a fraction, it's a plain old equation. We want to get our x's together. So let's subtract 24x from both sides. Those x's are going to cancel out, and we'll have 72 equals 12x minus 108. Our x's are together. We need to get rid of this negative 108 by adding 108 to both sides. Those cancel. Add this up. Gives us 12x equals 180. Divide both sides by 12, and x equals 15. All of this is old stuff that you should be pretty good with. The only new thing is this cross multiplying to get rid of the fraction equation. Now, when you solve rational equations, it is very important that you go back and check. It's a good idea to check all equations, but rational equations sometimes produce things that are called extraneous solutions. Those are numbers that look like they are solutions, but when you plug them back in, they don't work. Now, you may not want to do the full-blown stick a 15 in here and do the arithmetic. At the very least, you need to check that this 15 that you'll put in for x does not create a 0 in the denominator. 15 minus 3 is 12, so that's fine. Put a 15 here. 15 plus 3 is 18, that's fine. Pretend our answer had been 3. If we had put 3 back in here, 3 minus 3 is 0. That means we'd have the expression 24 divided by 0, which is not possible. So any solution you get that creates a 0 in the denominator needs to be thrown out. Doesn't happen all that often, but when it does, you better find it or you're going to get the problem wrong. All right, another one with cross multiplying. Very simple. Fraction equal to fraction. Cross multiply gives us 16x minus 48 for this. Cross multiply here. 12x plus 48. Let's get our x's together by subtracting 12x from both sides. Those cancel. Over here, we'll now have 4x minus 48 equals 48. Be careful, these two 48s don't just cancel out because that's a negative 48, that's a positive 48. So now let's try to get this x alone. Undo by adding 48 to both sides. Those cancel. We have 4x equals 96. That's a one-step equation now. Undo that multiplying by dividing by 4. And x equals 24. Same thing with the check. Put 24 in here. 24 plus 4 gives me a 28 in the denominator, which is fine, which is really 16 over 28 if you want to do the real full check. Put a 24 in here. 24 minus 3 is 21. That's okay. That means 12 over 21. If you want to know for absolutely certain that this is the correct answer, cross multiply those. If those two products are the same, then you know that this answer is correct. At the bare minimum, just plug it in and be sure you have not created 0 in the denominator. Now, this is a different problem, sort of, because it doesn't look like it's fraction equal to fraction, but very simply, I could make this into a fraction by just putting it over 1. Now I have fraction equal to fraction. I can cross multiply. Gives me x squared plus 2x equals 3. Here's where things are different. This is x squared, blah, blah, blah. If you have x squared in the equation, you can't just get your x's to one side and your numbers to the other. When you have x squared in the equation, that means you have what's called a quadratic equation. And if you're going to solve a quadratic equation, everything has to be equal to 0 on one side so that you can factor. So we're going to need to subtract 3 from both sides, which effectively just moves this 3 over to the other side. And we get x squared plus 2x minus 3 equals 0. To solve this, because it's got an x squared in it, we're going to have to factor. So to solve a quadratic equation, get everything on one side equal to 0 and then factor and solve. This is old stuff for you. The new thing was the cross multiplying. This is the correct factoring for that polynomial. Once you have something times something equals 0, this is where you get to use your zero products property, which says if these two things multiply together give me 0, one of them needed to be equal to 0. So I don't know which one. I'll say x plus 3 could equal 0 or x minus 1 could equal 0. You have two simple little equations to solve. To solve this, do the opposite, which is subtract 3 from both sides. On this one, do the opposite, which is add 1 to both sides, which gives you x equals negative 3 and x equals 1. We do need to check. If I put 1 in for that x, I would have a 1 in the denominator, no problem. If I put negative 3 in here, I'd have a negative 3 in the denominator, no problem. That says both of these answers are correct. Similar problem, think of x minus 6 as x minus 6 over 1. Cross multiply. It needs to be equal to 0 before we can factor it, so subtract 7 from both sides will give us this polynomial, which factors as x minus 7 times x plus 1. If you're having trouble factoring, go back and review all the factoring videos. If this times this equals 0, then either this is equal to 0 or this is equal to 0. So two simple equations set up to solve. Solve this by doing the opposite, which is add 7 to both sides. Solve this one by doing the opposite, which is subtract 1 from both sides. So these are my two answers. Plug both of them in for x, and I'm okay. Negative 1 in the denominator is fine. 7 in the denominator is fine. Now, if you wanted to do the full entire check, you don't just put the 7 in for that x, you put it in here. So put 7 in here. 7 minus 6 is 1. Put 7 in here. 7 over 7 is 1. That assures you that you have it correct. Same thing's going to happen if you plug the negative 1 in.